It's my pleasure to introduce Greg Aumann, our next speaker. He's going to be talking about challenges implementing egress controls in a large AWS environment. We'd like to thank our gold sponsor, Datadog. As always, we'll have the question thread in there. Please also remember to scan the QR codes outside and send your session feedback. It really helps the organizers pick and sort the talks for next year.
Well, I hope you all had a good lunch and are feeling refreshed. Not too sleepy. So I'm going to be talking about challenges implementing egress controls in a large AWS environment. I'm a member of Block's cloud security team, but most of this work has been done when I was a member of the product security engineering team. And until recently, that team was responsible for managing the Afterpay AWS environment. So Afterpay was acquired by Block 3.5 years ago. So, what I'm describing is the Afterpay AWS environment, which from a networking point of view looks very different to the Block environment. So you can't, so former Block employees probably won't recognise it at all. A little bit about me. I've been securing AWS environments professionally for the last 8 years. Before that, I was an AWS infrastructure or platform engineer. And further back, I've had several roles where I was basically doing networking, which was why I ended up with this project. What do I mean by large? So this tooling is processing approximately 25 terabytes of egress traffic per day and consists of nearly 200 VPCs spread across 6 regions. Okay, so I'm going to start by discussing the threats this control is intended to mitigate, the architecture that I used, and give a brief intro to AWS Network Firewall so that you can understand some of the challenges that I faced. I'll talk about the volume of the logs and the cost of the logs, and also something about the cost of the egress solution. So the volume of the logs posed quite a challenge, both in terms of the cost of them and in analysing them. But there were ways to reduce the cost. In allow lists, I'll talk about some of the challenges in creating and maintaining them. Then I'll talk about a few ways to bypass the network firewall, and maybe some ways that you can prevent people from bypassing the network firewall. The volume of the logs meant that I needed to use AWS Glue to help analysing them. And also, there was an oddity I found when migrating VPCs using AWS Glue to network egress. So that wasted a fair bit of time. So I'll hopefully save you some time if you ever encounter that. And then I'll talk about some missing AWS features. So missing from network firewall and also from AWS networking. Things that would have made the project easier if they had been there. So the threats that this control is intended to mitigate is exfiltration of sensitive data, customer data in particular, and we want to also block command and control traffic. And there are the main mechanisms by which people might do some of these things are network traffic, DNS traffic, DNS exfiltration, which is fairly well known, and using VPC endpoints. They're the primary mechanisms that you might exfiltrate data out of AWS, but by no means the only ones. So this shows a typical VPC architecture of before this project. So we've got ingress traffic going to a load balancer, going to EKS. This is just a typical example. Most of our VPCs didn't have EKS. They had lots of various things in them. And then they had NAT gateways and egress traffic going out the NAT gateways. And we actually had a pre-existing transit gateway network so that the VPCs could talk to each other. And that is fundamental in the solution that I chose. So the current infrastructure, we've deleted the NAT gateways out of the workload VPCs and also changed the route tables to send egress traffic into the transit gateway network. And then we have 6 inspection VPCs, 1 in each region, with a network firewall and NAT gateways. So and then the logs are going to an S3 bucket in a separate logging account. So note that I've put the firewall before the NAT gateways. That's fairly important because that means that the firewall is seeing the private IP addresses of the of the source of the traffic, and that makes it very easy to identify which VPC or which EC2 instance or whatever is the source of the traffic. If the source of the traffic is Kubernetes, sometimes it's a bit harder than that, but for other things it makes it quite easy. And it also means that you can have different rule sets in the firewall for the different VPCs. So you could have completely separate allow lists for each VPC, which you probably want to do. So our network firewall produces 2 kinds of logs. Flow logs, which are very like VPC flow logs, except they have a flow ID in them as well, and alert logs, which are more oriented around the protocol. So if for HTTPS connections, it will tell you the SNI, and it will tell you the version of TLS, and it will give you the server certificate, and other stuff too. It's too much to enumerate. And other protocols have similar levels of information. So AWS Network Firewall is based on the open source Suricata intrusion detection prevention system. And AWS supports Suricata's rule syntax. It also provides a simplified syntax tailored for ease of use. AWS documentation tends to focus on standalone deployments using simplified rules. So like the beginner, getting started when you don't know much about what you're doing, rather than the large-scale environments where Suricata's full capabilities are more useful. Okay. Oh, and the alert logs have flow IDs as well. So that makes it very easy to join the 2 log types together to correlate them. So the log volume and egress cost. So it's very difficult to estimate the cost of the logs because the volume of the alert logs is very dependent on the particular rule set that you're using, and it can be dramatically different. And so the only way I know how to estimate is to put a particular rule set in place, send some traffic to it, and just assume that the volume of the logs is proportional to the volume of the traffic. It seems to roughly work, but only roughly, because I've got 6 regions to compare and I can see that the ratios are not the same. In a busy day, so probably the highest traffic day of the year, this system is generating 280 gigabytes a day of alert logs, and flow logs about 3 gigabytes a day. So that ratio really surprised me. I was expecting the flow logs to be much bigger than the alert logs, but it wasn't the case. And this is because I've got the rule set I'm using, was using at this time, is a fully monitoring rule set. I'm logging all the traffic so that I can see what's going through. And that's one of the preparatory steps to creating allow lists. So one of the problems is that the Suricata has a nice threshold feature where you can do exponential backoff on the volume of the alert logs. And that would have been extremely helpful because the alert logs have a massive amount of repetitive information. And it's not adding all that much, and we could dramatically reduce the volume if this feature had have been implemented. The volume of the logs was such that analysing them was very difficult. So when I first started trying to use Athena to analyse them, I could only query 12 hours. That was before Athena timed out. So I had to convert them into Parquet format, which is a log format often used by data engineers. Which let me, and that improved the querying speed by about 30 times, which meant that I could generally query a month at a time, which was more what I needed to be able to do. And as part of that conversion to Parquet, I also annotated all the logs with the name of the VPC that originated the traffic. That made it much easier to query because trying to query random CIDR blocks in works well when it's /16 or /24, but if it's somewhere in between, it's quite difficult. And with the visibility, sorry, I'm getting behind. With the visibility that that the network firewall gave me, I was able to attribute costs to particular traffic flows. So when the data lake was the data team was copying Kafka events into the data lake, then I could say exactly how much that traffic contributed to the cost of the network egress solution. And that's the kind of visibility that I don't know how else you can get. And because of that, I was publishing charts of what was the most expensive traffic each month as a way to encourage people to re-architect their solutions and get the traffic down. And I found that one of the biggest contributors to the egress costs was our vendors. So in particular, in the Kubernetes VPCs, 48% of the egress traffic was going to Datadog domains. And some of our other vendors were also big consumers. But the good thing is that most of those vendors enabled you to have support private link connections. Because they're our vendors and they've gone through the due diligence process, we know exactly where it's going, and we don't need to send it through the network firewall. So we just send it via private link connections, bypasses the network firewall, and dramatically reduces the cost. And actually, I found that if all the cost-saving opportunities that I identified were actually implemented, we could reduce the cost of the network egress solution to below the cost of not having it because of the increased visibility, significantly below the cost. So like it was half of the cost of just having NAT gateways and no network firewall. Yeah. So creating and maintaining allow lists. Sorry. When you start looking at the traffic, you're going to find lots of surprises. People doing all kinds of crazy things. And in my experience, application owners seldom have an in-depth understanding of where their egress traffic is going. That means that you can't ask them what should be in an allow list. They will know some of it, but they will miss a whole bunch of stuff. So that means that the only way to create an allow list without breaking everything is to observe for several months. So that's why I was using monitoring rules. And then there will be some kinds of traffic that you won't like, and you want them to modify their application or configure them differently. Maybe they're sending unencrypted traffic, stuff like that. Also, once you actually put allow lists in place, you can't maintain those allow lists unless you're actually logging the traffic that's passed. Because say an allow list has been in place for a while, you can't remove a domain unless you know that it's no longer being used, otherwise you're going to break something. So it's very important to log the traffic that is actually allowed. And network firewall makes that is a little bit difficult because the default rule set is the default rule ordering that you get out of the box is groups the rules by the action type, and the pass rule comes before alert rules. So if you're using default rule ordering, it's impossible to log the traffic that is passed by the allow list. So that means you've got to switch to strict rule ordering. And if you need to do that, be warned that the Terraform provider is buggy, and I had to manually delete everything and recreate it with the different rule ordering. It couldn't actually change it. Okay, bypassing network egress controls. So you can forge the SNI field. Network firewall can't detect that. You can use encrypted client hello. So this is something promoted by Cloudflare and other people. So to support private browsing that uses encrypted DNS, and even if you're actually decrypting the HTTPS traffic, you can't find out where it's going. So the only mitigation is to just block encrypted client hello traffic, which is what the great firewalls of Russia and China are doing. DNS exfiltration, you'd want to block DNS traffic to external DNS resolvers, and you want to have DNS logs of the .2 resolver, and maybe you might want to use the DNS firewall as well and use the same allow list in the DNS firewall as you're using in the firewall. VPC endpoints are a great place to extract data, but they're quite tricky. So the obvious thing is to put something in the policy that only allows communication with other parts of your organisation, but that will break a whole bunch of services, especially in an S3 endpoint, because a lot of AWS services depend on being able to access special Amazon buckets. And that is not very well documented. A colleague of mine recently published a blog post explaining how you can exfiltrate data using EventBridge. There's a link to that in the references section. And I think in order to get good protection, you need to use a multi-service approach. So I would be using network firewall, DNS firewall, CloudTrail network activity logs, and combine it all. Okay, Glue challenges. So I deployed the network egress to a VPC that had AWS Glue in it. Glue was extracting data from a database in the VPC. All Glue jobs immediately failed. And why does that happen? Because Glue needs a connection to S3. It had a connection to S3 via the network egress that was working, but Glue's way of detecting that it has a path to S3 is to say, is there a NAT gateway in the VPC, or is there a S3 VPC endpoint? It doesn't actually test that the networking works. Missing features in AWS. So there's block VPC access. It would be really nice if, because we're using distributed ingress, centralised egress, it'd be really nice if the block VPC access supported that, but it doesn't, because AWS is much more concerned about ingress traffic than egress traffic. Yeah, so it would be nice if that had an egress-only mode, which means that I can prevent people from bypassing the centralised egress. If there was an ingress-only internet gateway, that would be really nice. There's an egress-only one, so it should be possible. If they implemented Suricata threshold rules, we could deal with the log volume much better. And firewall logs in Parquet format. So VPC flow logs, there's an option to save them in Parquet format. That would have saved quite a bit. Okay. This is the references. I'll leave that for a bit and we better take questions because I'm slightly over.
All right, we're going to start with a question from the room. Let me pull this one up. And this one comes from Eli. It says, during analysis, how did you do traffic attribution to specific applications? I found it challenging to translate the source IP in, for example, the VPC flow logs, to specific instances or nodes due to ephemeral workloads and IP turnover.
So in Kubernetes, it's very difficult because our Kubernetes architecture has multiple pods on a node. So the firewall gives you the IP address of the node, but then mapping it to the pod is a massive challenge. But Datadog was very helpful with that. For other kinds of traffic, you have the domain and the source IP, so it was pretty straightforward.
And our next question comes from David. How are you layering the various firewall services, DNS and network, to create a more comprehensive solution? And wouldn't this introduce potential issues?
So I haven't actually combined them all yet, but I think the DNS firewall needs to be in the actual source VPC, whereas the firewall is in a separate VPC, and you need to match the allow list, the per VPC allow list, to the DNS firewall allow list in the VPC.
Any questions in the room?
Thanks. I imagine this is pretty expensive with the volume of traffic that you're working with here. Have you investigated alternate options for either the NAT gateways or those network firewalls, just due to the traffic costs? Like, have you looked at something like Alternat or any of those kind of projects?
We have deployed used just the DNS firewall in one VPC. The DNS firewall is very cost effective, but the protection is not as high. But also, this is where the cost savings come in place. So it's possible to actually save money by putting network egress in, because you find all this traffic that no longer needs to go through the NAT gateways. So the savings from the decreased NAT gateway traffic outweigh the cost of the firewall processing.
I've got a two-part question. So one of the threats you mentioned was exfiltrating sensitive data.
Yes.
How did you actually get in the middle of understanding if the data that's being moved out was sensitive or not? And you were talking about bypassing using like ECH or TLS even. So how do you kind of get in between that to know if sensitive data is being exfiltrated?
So we're not, we're just trying to block all movement of data out except to known destinations. So we're not worried about whether it's sensitive or not, because command and control, the same thing blocks C2 traffic, and that's generally not going to be sensitive data, just harmful data.
Just a question regarding known destinations that you just mentioned. Have you had the case where you encountered, like, for example, jump hosts or like hosts that you cannot predict the destinations, where there's like a lot of potential destinations out there?
So we're just looking at destinations outside of our environment. So they're sent traffic via domain names, DNS queries. So we're just doing that. We're not looking at, it's not analysing traffic within our network, where that would be a much bigger problem.
Workloads that you cannot restrict because they might request a lot of domains.
They're not going to that many different destinations. It's usually massive numbers of requests to a smaller number of destinations.
Maybe just two more.
Okay.
On that same topic, like for a build environment where there could be a lot of different URLs or external repositories that I would need to reach out to, does it also go through the centralized egress point?
That's the case where we're using the DNS Firewall because of the volume of the traffic. But if you're worried about, you probably want a lot of build artifacts to come from your own artifact repository rather than publicly available in order to address supply chain attacks.
And last question.
Did you run into anything where the domains will be dynamic because they're fronted by a CDN or anything where there's lots of extra hops? We've had issues with that trying to implement allow lists, but there's lots of secondary domains that you'd have to capture as well.
Well, that's essentially what the encrypted client hello does. So it goes to one domain such as Cloudflare, and then encoded in the traffic is the real destination. So you want to probably block that traffic.
All right, thank you very much.